Hey guys, my name is Rajesh Iyer. I've been at Capgemini for about 5 months now. 23 years in the P&C industry, about 17 years in data science. I've been with driverless AI since late 2017 and H2O for a bit longer than that. Very interested in explainability because I only work with regulated industries, so working with banks and insurance companies.
Hi everyone, I'm Taposh Roy. I'm from Kaiser Permanente in the healthcare space. I've been with H2O since 2014, right when they had their first H2O conference. And it's been an amazing journey since then. Yep.
Agus Sudjianto. I'm from Wells Fargo, the head of corporate model risk for Wells Fargo. At the end of the day, if any of the Wells Fargo model in the news or go awry, my head is the first one to get chopped off. Background is engineering. I'm an engineer that went dark. I used to design engine for Ford Motor Company before I went to the dark side of banking.
Okay. Do you guys want to take a seat? You're fine standing? Totally up to you. Totally up to you. If you'd rather stand, please. Okay. All right. They want you on the chairs. They want you on the chairs. All right, so I have some kind of feeder questions, but I really want to impress on you, that now these questions about will the regulators accept this stuff? Is this actually going to make any money? Ask these questions now because I want to know the answers to these questions. Okay, so I have some feeder questions I can use to get started, but we really want this to be interactive. Okay, and you have some people who know a lot and have been doing this for a long time and from different industries up on stage, and I hope we'll be able to take advantage of that. Okay, so I'm going to start with, do you believe there's a trade-off between the accuracy of machine learning models and the interpretability of machine learning models? It's something that we talk about and people write about, including me. But have you ever seen this trade-off between a machine learning model and a more traditional linear model in practice, where you've really had to sacrifice accuracy for interpretability? Is that trade-off real?
I'll take a shot.
Okay.
So I think that interpretability is somewhat about regulators, but it's also a lot about change management as well. If you actually put a model out there or a system out there or a solution out there that people can't buy into, that's a huge problem. When regulators are thinking about explainability, I think it's more from a bias standpoint. So they ask a lot of transparency questions, but sometimes we end up making really complex models if we can actually show them that they're not as biased. And I'm not sure about every nook and cranny and every function and every model that happens in banks and insurance companies, but I think there's just lots of opportunity for us to actually use bias to get to the regulators and get them to see that it's not biased. But I think interpretability is super important, even when it's not, when you're making models in a non-regulated sort of domain, because you got to get people to buy into what you're making. Does that make sense?
Definitely. Taposh?
Yeah. So you gave the answer, actually. So I definitely don't believe that that's the case, that if you had more interpretability, you lose accuracy, unless you're doing Kaggle and you really care for your last 2 digits and to get a rank #1 spot. But other than that, if you're doing real world modeling, it doesn't matter. There are been areas of interpretability used before as well. I mean, surrogate models have been around for a while now, and people have been doing that. So I agree with you on the statement that it doesn't matter in the real world applications.
Okay. Thank you. Agus, trade-off between accuracy and interpretability, what do you think?
I think the statement that building model in real world is not Kaggle competition is true. Okay, so that's something that we don't compete on like Kaggle, stacking a bunch of model to squeeze every drop. That's not real world, right? Real world is model that we know what can go wrong with the model and how to deal with them, because all models are wrong. We know that, right? So that's understanding what the weakness of the model and really understanding and managing that. That's the critical one. After saying that, though, I'm a little bit biased here because I have a pet peeve. Yeah. So we can build very sophisticated model that can also be interpretable. So I think that's I truly believe that.
I truly believe that too, and that's if there's one lesson that I'd love for people to take out of this session is what Agus just said. You can build a accurate, complex model that's not just a linear model, but a model that's also directly interpretable. And this is both new and old ideas.
So yeah, that's my
Okay.
answer.
Okay. So is the audience going to ask questions through Slido? Is that how this is going to work, or should we check? Should we check to see? Okay. Okay. That's fine. That's fine. All right. So I'm going to ask Taposh this question because I think for the financial services guys, we get it. Taposh, in your industry, health insurance, right? What are the drivers for interpretability? What is the business driver for interpretability?
So first I'll say that it's more than health insurance. We are a healthcare provider. We are
Sure.
a ACO. So we do both. We have hospitals. We do also insurance. We have a big pharmacy as well. For us, overall health of the people is the most important thing, right? So anything that we do should create value for the people at the end of the day. It should create value for the physicians or whoever is using that model. We were using simpler models before because models were there in healthcare for a while. So to answer that question, your question was, does it make sense to have interpretability?
What are
Yes.
what is the business driver? And you're saying human life, which is good.
Care, which is the most important thing for us, is the biggest business driver.
Yeah.
I mean, there is no value you can put it on the life.
Right.
So that's the most important driver for us. Other than that, everything is a sort of process in a way.
Okay.
So my answer is
Okay.
life.
Okay. That's a great answer and an answer that I would agree with. And one thing I said, we really want to start making systems that are appropriate for both business critical but also life critical decisions. Machine learning models are going to be deciding important things in our lives in the future, most likely. I mean, it may not happen, but I think it probably will. And so we just need to understand how they work. All right. To Agus and Rajesh, is there something besides regulation that drives interpretability in your businesses?
Yeah, I think it's not really for us. Yeah, regulation is there. We have that, but we pass off that. So for us, the danger not only regulation. We're talking about making decision that impact our customer, and that's is a serious thing, right? So decision that impact our customer. And also decision that probably have large financial impact for us. Bank is run by model. We lots of model for making decision, and decision that will stick for a long time because we originate loan and we stuck with that, right? Bank making money from taking your deposit that you can take anytime, but when we lend money, we stuck until the next recession and post-recession. So the implication is huge. So understanding what the driver of the model is that makes sense. Not only, hey, the model with the sample, out of sample test, it looks wonderful, but out of sample test is limited, right? And we're dealing with going through different cycle. Then human being, when we look at what variables are important, we accumulated a lot of knowledge. We have a lot of people that really understand the business. Then looking at the effect of the variable, the importance of variable, human being have more trust. This model makes sense. And if it has some weaknesses, then we know what to do about it. Talk about model will be wrong, so we know where the model will be weak from the interpretability point of view. Then we're looking at what's going on. a lot of things when we look at the interpretability tool, and this is something that's really true. You run your model, it looks wonderful on out of time sample, and look at the area under the curve, makes sense. But when you look at the interpretability, then you start seeing non-monotonicity, you start seeing some spike here and there, and then you start seeing what's going on. And most of the time, many times, it's data problem, right? Because we're dealing with very, very large data, and do we know what's wrong with the data? Because we know we do data cleaning, we do some augmentation on the data, all the data in our system is not clean. So interpretability is important to really understand your data as well.
Nice. Okay, so interpretability, why is interpretability important to you aside from regulation, Rajesh?
So maybe I can make a better link this time around. So basically, when we try to build some kind of AI for sort of help people make decisions, right? So underwriting on the insurance side or banking side, loan approvals, whatever you want to call it, we build a solution, and I guess it's good to build an accurate model, but then I think it's really important to actually be able to explain what's going on to a user, and then letting them override where it doesn't make sense, and then kind of using that back. So we don't get that focused on the accuracy. The first pass we want to do is, basically I believe in creating a closed human in the loop AI system. So you build a model first based on some offline data, you put it into production, you let users take a look at what's going on from a prediction standpoint, what's going on from an explanation standpoint, and then collect feedback back, so let them have the ability to accept it or override it. And then maybe what we're thinking about right now is actually using things like Walpole Wabbit or FTRL or whatever it is to create that feedback loop to keep improving
Online
the model.
Online
so
learning.
that's what we've kind of built the components of that stuff. You can't always do that, but where you can, we want to do that. So it's not. We're not about accuracy being the end all.
Right.
It's about humans pushing the systems and the systems pushing the humans.
Cool. Awesome. Okay. So you may have noticed we have a new panelist. So I'll let you introduce yourself, and then I'll give you the opportunity to answer the same question, which I will repeat for you.
Oh, thank you.
Yeah.
I missed it. Hi, I'm Marc Stein. I'm founder and CEO of Underwrite.ai. And we build nonlinear models of credit risk and also cancer risk. And the reason behind that is that I have a strong sense that most of the world's serious problems are inherently nonlinear and are attempted to be solved with linear technologies. And that results in a lack of efficacy in many of the problem-solving steps. That if we have a nonlinear problem, we need to solve it with nonlinear equations. And we found that to be particularly the case both in cancer diagnosis and in consumer credit. And that's been the focus of the company for the past year. So we build credit models largely aimed at increasing credit availability to underserved markets and underserved communities around the world.
Awesome. Okay, and I think this is the last question we'll do, and then we'll turn it over to the audience, see if you guys have any questions. So the question was, aside from regulation and just being fined to death and breaking the law, why is interpretability important in your business?
Well, I think I look at the foundation of the regulation in the United States, which we then really apply throughout the world. And the regulation surrounding explainability in the US is the Fair Credit Reporting Act. In the EU, it's GDPR. The fundamental of it is that if someone comes to you and wants to borrow money and you look at their credit file, you either have to grant them the money or you have to explain to them in terms that they understand why you're not granting them the money. And the purpose of this is both fairness, and it's right, but also it's to give the person who's being denied a loan an opportunity to correct the problem that prevented them from getting the loan. That's the fundamental issue of explainability. What we do in our modeling, and we use DAI for this, is that when we return a decision, it is the probability of an outcome. So typically we model the probability of a profitable ROI for the loan. If the probability falls below a certain threshold, some lenders it would be at 0.8, other lenders it would be at 0.7. But if it falls below that threshold, then the loan is a decline. We then need to look at why the loan was declined. And explainability in this case is to look at the variable weights that drove the individual decision, correlate those to outcomes that are accepted in terms of the credit bureau and the CFPB. So we correlate them to acceptable adverse action codes and reasons, and we deliver them to the lender in addition to the decision. So to me, it really isn't about regulation. I think the regulation is fine. We're doing loans in rural Mexico. We tell people why we're not giving them a loan. We do loans in the Philippines. We tell people why we're not giving them a loan. You don't have to wait for the regulators, and you don't have to do it under threat of penalty. It's just the right thing to do.
I like that. I like that a lot. Okay, so let's see if there's some audience questions, and if not, we have a couple more questions that we can go through up here. Oh, great. Okay, let's see. Unfortunately, I can't really see them. Yeah. What do we think? Do we want to stick here, like just Slido, or do just okay? They're giving me a strong indication to just do Slido. Okay. 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 All right. So I'm going to start with the top one. In terms of adoption of AI, what is the proper role of interpretability in establishing trust? So let's try to refine our answers from a little bit general to more specific around what makes you or your business partners trust a model, and how is that related to interpretability? So you have the mic. You can start.
I have the mic. I was always struck by something that Richard Fineman said, which is that if you can't explain something to an elementary school student, then you don't understand it very well. I think that the issue of explainability is it should be explainable not to a PhD in data science. It should be explainable to the consumer or the end use. And I realize that there are, different levels of complexity and different levels of explanation. But ultimately, it comes down to you have a target market who you need to explain to. And you need to be able to speak in a language that they readily understand. And lights out.
Yeah. I'm going to assume there's not some kind of emergency that somebody just leaned up against the light switch.
Siren.
Yeah.
I probably take a little bit different spin. You have to be similar to Marc, that interpretability is you have to be able to explain the model. You have to be able to understand your model. But in our standard, and John Walter's standard there, is my peer for Bank of America, you have to be able to defend it in front of PhDs. So if you cannot defend it in front of PhD that you really understand your model, that model will not be approved. It will have no chance to get implemented. So that's just how we work in banking, especially large financial institution. John and I made the final decision whether model can be in production or not. So first of all, if you wanna have a chance your model to be in production, you have to be able to explain it, and you have to be able to defend it in front of PhDs.
Cool. I'm gonna put a cap on this question if that's okay, because there are a lot of really good questions here, and there's one specific for consulting and there's one specific for healthcare. So I'm gonna pass this. In consulting, how do you sell interpretability to clients when you get challenged by internal teams with accuracy? I'm gonna pass that to Rajesh.
I keep trying. So when we build models right from the word go, right? So when we are actually looking at variables and stuff like that, we go through a process where we say for everything that we're trying to put into the model, do we know why we're putting it into the model? And if I can't explain, or if we have actually methodologists with so we have like a guys, the largest part of my group is actually guys that do models from day one. And whatever they're trying to do, they get help or they get coaching from the methodology guys. And whatever they end up building gets validated by the methodology guys. So one of the things that we try to do as we're trying to build models is we say, okay, here's the variables we're looking at. We ran some exploratory models. Here's what ended up at the top. They better be able to explain why every one of them is in there. And then we put it through the bias ringer, because there's a lot of stuff that looks great to us, but it might actually cause a bias on the other side. So we go through that very, very rigorous process as part of building a thing. And you got to realize that if we can't explain it, we'll just toss it out.
It's useless.
Yeah, because that's what's going to get me in all kinds of trouble when I go in front of the client. Right? I'm going to look like an absolute idiot if I can't explain why that variable's in there. What's the big deal? Throw it out. We'll find something else that actually works and we can explain. And you got to be very open to the iterative process and focus on, before there was any explainability stuff, before there was SHAP, before there was variable importance is not all that great at explaining what's going on anyway. Before all that stuff, we used to do this in the old school. When we built models, we always said, why are we putting this in the model? Can we explain why it's in the model? Can we explain why is it very important versus not very important, even based on variable importance back in those days? But I think that's an exercise you absolutely need to go through in consulting if you think that you're going to convince your client that you know what you're doing. Does that make sense?
Oh, to me?
Add something, Rob?
Please, yeah.
Yeah. Oh, thank you. Oh, multiple microphones. We don't generally have to present to boards of PhDs. I mean, we work with much smaller entities. We have to convince boards, typically, to go with a model. And one of the things that we've found that is effective is when you need to explain the explainability and explain how the model works, we always try to start with something that we know they agree with. And that kind of gets buy-in. So one of the things that we'll always do is if FICO is used in one of the models, right, we'll do a partial dependence plot on FICO. And we can visually show them, well, you see your FICO graphs to defaults up until 720, right? So the higher the FICO, the lower the default until you get to 720, and then it flatlines across, right? Well, now you've explained something to them in terms that they understand, and they're much more receptive to the more esoteric findings that might exist in the model.
I think that's concrete advice. I like that. Okay. I'm going to move on for Taposh.
Okay.
Can you name any special interpretability challenges in healthcare? Is there anything special that you think Kaiser or other healthcare companies are dealing with that may not be rearing its head in insurance or banking, or you think it's all kind of the same?
So there are different flavors of it, I would say. As far as businesses like banks go, you have to explain it to bankers who are PhDs, maybe in finance and stats, and don't know their stuff in and out. In our case, you might have to explain models to physicians or a board of physicians. And you need to explain them in a way that they understand that if heart rate goes up or down, it logically makes sense or not. So getting a model into production explainability is very important, because you not only want to explain them, we actually do one step beyond that, is we actually do actual case reviews and we actually simulate those scenarios. In order to get something into a healthcare into production that touches human life is very, very critical. So interpretability definitely has a huge role to play.
Nick, we're okay on time, right?
You have 17 minutes.
Oh, wow. All right. Yeah, no, we're good. I mean, there's a lot of really good questions here that I haven't even brought up, so that's great. All right, so
Patrick, can I say one thing?
Yeah, please.
Even though the question is not for me, but because of the natural language processing is pervasive, the interpretability for natural language processing, because suddenly now we're dealing with very large number of categorical variables. So I think that's something that we really need to work on the interpretability, because we have chatbot, all the text analytics and voice recognition and all of those things that we have to deal with.
Thank you. All right, so I'm going to go with this top question that has 4 votes. It's something that I'm really interested in, but honestly don't know that much about. And it's something that I know our academic advisors at H2O are very interested in. So we're starting to learn that machine learning models can be exploited for bad purposes, right? And I'd be interested to know if that's something that you've come across in your professional life, or if it's still just something we're kind of reading about in the newspaper. But will interpretability make machine learning models even easier to be manipulated by bad actors? And I think that's a really good question, and I think it's kind of a really leading edge question, and
The answer is yes.
Yeah.
I mean, that, if you're building adversarial networks and you understand the drivers to a network, well, it gets much easier. And yeah, that is a huge problem that we're all going to have to grapple with, because it goes to the question of, can we believe what we see? What can we accept as fact? Because typically, if we saw a video of something, we assumed that it was real. And now we're entering into this uncharted territory where it may be. And so we need mechanisms by which data can be validated, visual data can be validated, and whether that's by a crowdsourced vote or some metric by which we can ascertain whether something is real or not. And I think that that's another role for ML to play. So ML creates the problem, exacerbates the problem, and then eventually solves the problem.
So, but guys, it's a little bit of a red herring question, all right? Because what's the alternative? You don't build models at all? Are you going to make linear models that fraudsters can't take advantage of? It's really, I don't know where you go with that one. I mean, it's kind of like, we make it complex so that it's more difficult for them to actually copy it.
Yeah,
Right?
it's an interesting, I find it to be an interesting point. And, my commentary here is, the last time I was involved in an event like this, someone brought up that almost the instant the internet was invented, people were using it for hacks. Right? So whenever we're dealing with, and we're talking about the late 1960s, so whenever we're dealing with technologies, you can use it for good and you can use it for bad. And I think that is actually one reason to make the model more interpretable, right? It comes with an instruction book of how it works and why it works, so that someone, I can make a model and then it's just a piece of software and I can't really control how it's being used. But I would say if people can get insight into how it actually works, that's a safeguard against it being used for potentially nefarious purposes. It's at least a safeguard. But
I would say the other way around, Patrick.
Okay.
I would say the other way around. Because you are the proponent of post hoc and all of those things, right? So people can always reverse engineer the decision.
Okay.
You try it enough, you get sample, you'll reverse engineer it, you get the effect plot. Okay, so that is given, right?
Yeah.
Even you don't have interpretable model, we do this all the time, system identification, right? By having data and look at the output, you can reverse it. But I would say it's the other way around, to me. By understanding what variable, what are the driver, and all of those things, you should be able to understand what the weakness is and how it can be hacked. So I think that's
like
the
it.
most important.
Okay. Taposh, you?
No, I agree totally with him. I mean, the very fact that you are using monotonic, right, for every variable, it opens up for people to do the trial and error analysis, and fixing the weaknesses is the right way. I agree with you.
Okay. Great question. All right. So the next question with the most votes is, if a model can be explained, is it just a rule-based system and it's not that sophisticated? So let's maybe get into some of these examples of complex models that we've worked with that aren't just a simple rule-based system. So I'll let you go first, Agus. Yes,
Well,
you can talk about some of the things you've been working on.
I will talk about the extreme, because neural network is the most interpretable model. So
He's not joking. He's not joking.
I'm not joking. You can read my paper in archive. There are 2 of them. One is called explainable neural network. The other one is how to constrain neural network to be highly, highly interpretable. It's in public, so a neural network is not black box. Neural network is a spline machine. We know all these things, and we can make it extremely, extremely interpretable. More interpretable than the crazy ensemble model, yeah. So any GBM and all of those things by nature is not interpretable. We can do a post hoc analysis to make it interpretable, but we can build model that's from the ground up, very sophisticated, deep learning that can be interpretable, very interpretable if you know how to constrain it.
Okay. Any other examples on the panel of using models that are complex but aren't just rule-based systems?
Yeah, I think fundamentally, I mean, there's a key difference. I mean, when you look at credit modeling in the traditional way, and you look at the 4 attributes of FICO score, debt to income, inquiry count, and trade line performance, the reason why people build models with 4 attributes is very simple. You can write a rule set that deals with all occurrences of those variables. You can build linear models, and most importantly, a human underwriter can hold this in their head. When you take 2,500 variables and you build a set of 19,000 combinations of 2,500 variables, and you develop a model like that, there's no rule system that can encapsulate that model. So fundamentally, this is the difference between a complex model is you can't keep it in your head. That's the biggest thing.
Yeah, I mean, just to basically say, I mean, the learning process is probabilistic, but the inferencing process is deterministic. It's all rules at the end of the day.
I'm going to make a little bit extreme here, okay?
Please.
What is the most popular machine learning model? GBM, random forest. Random forest is rule. It's 3. It's rule. You average 1,000 of rules. GBM is 3. It's rule. You weighted average the 3, the rules. So GBM and random forest are rule based,
But you
right?
can't hold them in your head.
Yes, it's a lot
Well,
of
it's
pages.
okay because it's the same
Lot
thing.
of rules.
The old way we have rule based, 1,000 rule based system in our fraud system. Now we just quicker rather than manually build rule. Let random forest do it. There's 1,000 of rule right there.
Or 600,000?
Or 600,000 of rule.
That's
You have
not.
the explanation for every rule now. Then yeah.
Yeah. All right. No, I told there's some interesting questions here. Okay. And I'll just name quickly. You guys can go look these up. Things that we're interested in. So one thing I would have you go look at is, and it is a rule-based model, but scalable Bayesian rule list. If you're interested in complex models that are directly interpretable, scalable Bayesian rule list. Super sparse linear integer model is another one. Agus said X and N, which we're highly interested in implementing. My personal favorite is the monotonically constrained GBM. So there's a lot of things that aren't just sort of COBOL rule-based systems that are highly accurate and interpretable. But that's a really good question. Yeah, rule fit. We have rule fit. We have that in driverless AI. Okay. Does model interpretability say which feature causes my loan to be not approved? Can it say how much change of that feature will make my loan get approved? So can we be prescriptive? So I think it's kind of an easy question, but probably people in the audience would like to know exactly how. And Taposh, you have any comments here? You want to pass it off to the financial services guys?
The financial services guy will do more justice.
Okay, that's fine. That's fine.
Yeah.
Okay, all right.
That's exactly recent code.
Okay.
Yeah. It's not so much, a direct output. What we know from the output of DAI or the output of any interpretable model at a transactional level is what were the variables that drove the decision and what were the weights of those variables. So we have variables that have positive weighting that made a positive contribution to getting the loan, and we have variables that have negative weighting. So the variable that has the lowest negative number is the one that had the most impact on the decision at a simplistic level. Now, the next question is, what is the correlation to an acceptable reason code that's associated with? So if we find that the trigger to a decline was a 60-day late, right? It's not a rule-based system because there are 60-day lates that we might approve given other conditions. But what it really is this is an explanation of why in this particular case. And we can provide up to 4 reasons. But they have to be reasons that are acceptable under fair lending. So one of the things that we look to do is to correlate the reasons within the model, and we try to constrain the model so that the inputs are only FCRA approved values. So for instance, when we build a model, we won't accept a zip code. Why? Because the zip code is a proxy for race. We don't know the names of the borrowers because names are a proxy for gender and ethnicity and religion. So we've stripped all that out, and ideally what we should be left with is a set of attributes that will correlate to acceptable adverse action codes. And that's what we do.
All right, I'm going to rephrase the question a little bit and pass it off to Rajesh. So any comments, Rajesh, on what-if analysis, right? Like, is that something you do in your work? Is that, like, how do you use the model itself to be prescriptive about what a person could do to not get denied? Or what a person could do to change their business, or that kind of thing?
I mean, we could do it, but I don't know why we would do that very often.
Okay.
So basically we're saying, okay, this is what we found. We might take a few of those and make sure that it sort of makes sense to us. But I don't know if I'd actually simulate and say what happens if you actually move this variable up or down.
Okay.
Just trying to figure out what the practical application of that is.
Okay. So I would say that like what-if analysis is something that we're really interested in at H2O because, and that's why I picked this question. I think while for the accomplished, very highly experienced people on the stage, what-if analysis may seem kind of obvious, but for people who are just getting into interpretability, I think it's a really nice way to say, well, if I change this person from male to female, what does the model do, right? And then you get some sense of the impact of gender in the model. If I change the income from 50,000 to 200,000, what does the model do? And then you get some sense of how income is impacting your model. So I like the question because I think what-if analysis is a simple way to get some interpretability into your system.
We do that for stress testing.
Yeah.
Right?
Yeah.
So, I mean,
Yeah. Stress
but
testing.
we
Right.
basically
But that's
have-
very sophisticated.
Well, not really. It's just we take data from 2008, and we apply that to a current data set, and we look to see what's the delta between a decision in 2018 and 2008 when the world collapsed. And it's really not very hard to do. You know what attributes have changed most over time, and it's fairly easy to adjust those if you're just looking to run what-if scenarios. And that allows us, if we're dealing with investors in a fund, when they ask the question, okay, but how does your model react in a recessionary environment? Well, we don't have the exact answer, but we have a good idea.
And Patrick, from a healthcare standpoint,
please, yeah.
what if is actually very important for us because we would like to analyze the scenarios where how our model is performing, especially if it is related to clinical, even in non-clinical settings, to understand, okay, if something changes, if the heart rate is a certain way, what happens? Is the model performing within the boundaries or not? So what if is very critical for healthcare.
I'm making one comment here. Because we're dealing with a lot of model in financial institution, we always tier model from the most important to the least important. So every model has attached to it a tiering in terms of importance. And in terms of interpretability or explainability, we have different standard requirement for what kind of tool do you use. From the lowest tier model that we call it race rank 4, we expect people just do sensitivity analysis or what-if analysis. So you people can apply rudimentary tool, what-if analysis or variable importance, or the rudimentary stuff. Until the tier 1 model, where we require people to do a lot more sophisticated interpretability analysis. So it's very, and then for the model that we do use for For stress testing, we have our what-if analysis are really more how it runs under stress condition. That's more sophisticated. But in general, we apply different degree of sophistication on the interpretability from very simple sensitive analysis all the way to more exoteric stuff.
Okay, and we're almost done. I see Rajesh really checking out the question board. Is there one you want to answer? Is there one you want to answer?
There is one I don't want to answer, which is the top one.
Okay, all right. Yes, sure. Just very quickly, deep learning interpretability. Any comments from the panel? Do you see deep learning in your practical day-to-day work or ways to make it interpretable?
Well, you can answer.
For me?
Sure.
Well,
Tell us about it.
It varies, right? So from because deep learning is very broad. When we talk about deep learning, what are we talking about? The supervised learning, I'm assuming the standard supervised learning or generative adversarial network is a different things. But at the end of the day, if it's a supervised or generative adversarial network, it's a mapping. So it's mapping from input to output. So yes, we require the same thing. If it's crude deep learning, which is the ignorant way we apply deep learning, the answer is, yeah, you need to do post hoc analysis, input-output. The second thing is, this is what's beautiful about deep learning. Deep learning gives you derivatives, right? Give you dy dx, yeah? Give you dy dxi. Beautiful, and you even can calculate the total derivative to get the correlation, what's the effect of correlation among variables. So you can use the output of deep learning and the chain rule of deep learning for interpretation. Say some of you that interested in that, check the paper that we have in archive. Very detailed how to use that one.
You should. You really should. It's a
Right?
good. It's
Is
good.
there source
Sure.
code in GitHub that we can use?
Yeah. It's where's the developer? I think it's sit somewhere in here.
Okay.
Right
We better
there.
stop.
That
We
lady
better-
right there.
we
That
better
lady
stop.
right there wrote that paper.
Okay. And I can vouch. You should go read the paper. Matu's right here is implementing the paper right now. Okay. But we better stop. This was great, you guys. Great questions. Great input from the panel. So thank everyone so much. Let's have a big round of applause.